Lesson 8.2, Review Packet 8A. Which quadratic equation has no real solution? So we can use quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. So a is the coefficient of x squared, b is the coefficient of x, and c is constant. So let's take a look at b. So b will be, if you look at b, a is negative 4 because that's the coefficient of x squared. B is negative 12. C is 5. Plug the number in. We have x equals negative b plus or minus square root of negative 12 squared minus 4 times negative 4 times 5 divided by 2 times negative 4. Actually that b should be negative 12. Therefore that we have 12 plus or minus square root of 144 plus 4 times 4 times 5, which is 80, over 2 times negative 4, which is negative 8. At this point we know that inside a square root will be positive, so whatever that is, we have 12 and add we have 12 in front, so this entire thing will be real number. If we have some numbers inside which is negative, then that's not a real solution. So however, for b we have real solution, so b is not the right answer right there. So I want you to do the same thing for a, c, d. Not really I want you to do, but in order to find the correct answer, you need to do a, c, d so that you can find the right answer. B, find the value of k such that 3x squared minus 12x plus k has the following solution. A, two real number solution. Okay, let's do that. Let's use the quadratic formula again. So in this case, a will be 3, b is negative 12, c is k. And plug the number in. We have x equals negative b, which is negative 12 in this case, plus or minus square root of b squared, which is negative 12 to the second power, minus 4 times 3 times k, over 2 times a, which is 3. So we have 12 plus or minus square root of 144 minus 12k over 6. So if we have positive here, as if 144 minus 12k, see, if the inside of the square root is positive, then we have two solutions, right? If the inside of the square root is 0, then we have 12 plus or minus 0, which is the same thing. That actually means that if you simplify that, you only have one solution. So if 144 minus 12 times k equals 0, then we should have one solution. Okay? But if 144 minus 12k, which is inside of the square root, is negative number, then we have no solution, right? Because no real solution, because we're not supposed to have any negative numbers inside a square root or radicals in the real number field. Okay, so if you solve these three three equations or inequality differently, you'll be able to find A, B, C. So if you solve this, for example, so 144 minus 12k is greater than 0, so we can just simply, kind of pretend that it's equals 0 at this point. Subtract 144 from both sides. Then we have negative 12k equals negative 144. Divide both sides, we have k equals 12. Now we have k equals 12, but this is, we have inequality, so we have to find out, we have to kind of analyze, is it greater than 12 or is it less than 12? Okay, so you're going to plug the number in. For example, let's pick the easy number. If we pick 10, then let's plug that in for k here. So we have 144 minus 12 times 10. Is that greater than 0? Yeah, because 144 minus 120, that should be positive. So we should choose those numbers. So as long as k is less than 12, then this should work. That's the answer for A. In order to find the answer for B, you gotta do this part. In order to find the answer for C, you gotta do this part. For what value of x is x squared 6x squared minus 5x minus 4 negative? So in this case, you're gonna use the in this case, 8.2 is all about quadratic formula. So A equals, so use x equals negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. In this case, a is 6, b is negative 5, c is negative 4. Plug the number in, simplify it, and you should have two answers. And plug the number in to see if what makes this expression 6x squared minus 5x minus 4 will be negative. So that's that. 24. What values of x is each equation true? So we have this guy right there, x plus 3 over 2 to the second power minus x minus 3 over 2 equals 3 over 2 to the second power equals 3x. So there's some different ways to solve these problems, but I choose to do expand that first. Okay, or we can kind of say we can let a be x plus 3 over 2 and a b be x minus 3 over 2. Okay, then we can call it this a and this called b. So we have a squared minus b squared. That's the same as a plus b times a minus b. Okay, and then plug the number in, so we have x plus 3 over 2 for a plus x minus 3 over 2 for b, and we have x plus 3 over 2 for a minus x minus 3 over 2 for b. And then as well, we have the same denominator, so we can add just like normal number. So we have x plus 3 plus x minus 3, so the plus 3 and negative 3 cancels out, so we have 2x over 2, which is x. That's the left parentheses. It cancels out. If you look at the left parentheses, we have x plus 3 minus x minus 3. So, and we have the common denominator, so we can add just like integer. So x minus x, x minus x, that gives us 0. And then positive 3 minus negative 3, that's positive 6. So we have 6 over 2, which is 3. So x times 3 equals 3x. Right? So A is true. How about B? Okay? That's your problem. Problem 25, find the quadratic equation with roots x about 5 and 2. So that's the easy one. So if if x is 5 and 7, what kind of number those are the number you should put for x, plug in for x. Again, we kind of thinking backwards. What number should we have over here if we plug in? So we want this left parenthesis to be 0, and we know this x is 5. What should we have for next to it? It's definitely -5, because if you put 5 for x, then 5 minus 5 will be 0. And then what would you do for 7, right? So same thing. So that's how you do it. B, can you find a second quadratic? Well, after that, you gotta expand this one so that you can find a quadratic for that. And then can you find the second quadratic equation with roots 5 and 7? Third quadratic equation with 5 and 7. Yes, it is. It's possible. And you learned that in class, so please do that.